What's up, everybody? It's my 2020 view coming at you. So today I want to make an educational video for you guys about the square heart. Alright, so to get started, what we need is, of course, a piece of paper or a whiteboard, whatever, a blue marker, crayon, whatever you want to use, a red, and a black, green, something of an alternate color other than the red and blue. Because we're going to start by talking about the red and the blue. Oh no! Great. Guess my battery just went dead. Huh. Yeah, there you go. Alright, so we'll talk about the square heart. So we got a blue marker for deoxygenated, red for oxygenated, and then a different color, whatever you want to draw with, a green, black, whatever. So I came up with this idea while I was in school, kind of like, how can I make the structures and the blood flow of the heart a little bit easier? So this is what I came up with. I call it the square heart because to me it's a whole lot easier to draw a square heart so we can see the size of the chambers a little bit easier. So think like a window pane. So we know the top ones are the smaller ones and the bottom ones are the larger ones. So on the top, this is going to be the right side, this is going to be the left side. Remember, anatomical position, so you're always opposite of what you're looking at the patient. So I have to erase where we're going to put the valves in. Let's go ahead and label these. So this is going to be your right atrium, and I'm just going to put RA up here in the corner. I know it might be a little hard for you to see. And this one's LA, left atrium. This is your RV, right ventricle. This is your left ventricle. So remember, the heart is kind of divided up from the right side and the left side. Right side dealing with deoxygenated blood, the left side dealing with oxygenated blood. And we'll talk about that as we go a little further along. So right atrium, atriums are on top, ventricles on the bottom. The atriums contract at the same time, so they squeeze lub dub, lub dub, lub dub. So it's going to go from the top atriums, squeeze up there, pump blood into the ventricles, and then when the ventricles contract 0.08 seconds later, the blood is going to be ejected into either the lungs, into pulmonary circulation, or into systemic circulation. Alright, so we said RA, LA, RV, LV. Let's go ahead and draw these little valves in here. It's already getting a little sloppy, I see. Alright, so these valves, this is your tricuspid valve. This is your bicuspid or mitral valve. I know it couldn't be easy and just be tricuspid and bicuspid. Remember, these look like over here, it has 3 flaps to it. 1, 2, 3. That's where it gets its tri. And this one only has 2. 1, 2. So that's where it gets its bi from. So I'm going to go ahead and erase the valves there because we'll need the space here. So we're still using the black color marker. So next, what I want to do is draw the lungs. No, I kind of went a little. Hey, I never said I was an artist. Alright, so that's your lungs. And over here, we're going to draw the body. There's a little finger. There's the legs. And notice I'm not attaching the head to the body. There's going to be a reason for that here shortly. Alright, just kind of backing up, reviewing. Right side of the heart, left side of the heart, deoxygenated, oxygenated. Right atrium, left atrium, right ventricle, left ventricle. This is your tricuspid valve. This is your bicuspid valve in between the atrium and ventricle on the left side, or your mitral valve. If your tests are like mine, they're going to ask you mitral valve over bicuspid. I don't know why they try to do that. But at the bottom, we know the right side deals with deoxygenated blood. So it's going to pump blood to the lungs. So this one is called your pulmonary semilunar. That's your valve. This one is going to be called your aortic semilunar valve because that pumps blood into the largest vessel in the body, which is your aorta. So aortic semilunar valve. Alright, so from here we got all the structures drawn. Let's go ahead and cap our off color and get to our blue. Remember, our blood is either dark red or bright red. It is never blue. I know there's a lot of misconceptions out there saying, oh, our blood is blue until it hits oxygen. Think about that. Do you not have oxygen throughout your body right now? Even in your veins, you have some amount of oxygen. So that can even realistically be true. But for this purpose, we're going to make it blue because if we look at our vessels, our veins kind of have like a blue tint to them. So it is kind of a bluish tint. So maybe that's where they got the blood is blue. I don't know, but it's not true. So we're going to start in the right atrium. We're going to pump blood to the right ventricle. So from the right ventricle, we're going to have two vessels that come out that go to each side of our lungs. So let's go ahead and draw those in there. I always put like little arrows in so that way you can pick it up at any time and know the direction in which you're going. So we're going to call these your right and left pulmonary arteries because they're going away from the body. So we'll say this is the right and this is the left pulmonary arteries. Alright, so what happens at the lungs? We end up picking up oxygen, therefore making our blood bright red. And now that we have oxygen rich blood, we want to pump it back to the heart. Through the way of these structures. These are called your, and it doesn't matter if it's right or left, just know that there's two. So we're going to call this one your right. Oh, terrible marker. And left, I'll abbreviate, pulmonary veins. Alright, so your pulmonary veins, apologize for all the, I should have got a smaller tip marker for you. But these pulmonary veins actually carry oxygenated rich blood back to the heart, to the left atrium. And once it's in the left atrium, it's going to pump it to the right left ventricle. So from the left ventricle, it's going to pump it out to the body and to the head, all over the different parts of the body. I'm not going to go into all the different branches for this sake because we just kind of want to look at the major structures of the heart. We will go ahead and label this vessel since it's the largest. That's your aorta. So your aorta is the largest vessel in your body. It has the highest pressure because it's coming from the left ventricle. We know that left ventricle is really thick in muscle because it has to pump blood to the whole body. So once we get oxygenated, rich blood to the rest of the body, from there our capillaries exchange it for oxygenated poor blood, and now we have switched back to the blue. So our blood is going to be blue and now pump back to the right atrium through the way of the inferior vena cava. Now right up here, inferior vena cava, and the way of the superior vena cava. And this is your superior vena cava. So now the reason why we didn't draw a neck on here is because the inferior drains everything except for the head, and the head is drained from the superior vena cava only. So if you can keep them separate, then you'll remember that the superior vena cava drains just the head, inferior vena cava drains everything else. And once we exchange all that, come back to the right atrium, again the cycle just continues. So that's pulmonary circulation. One thing I do want to mention though is, as we were talking about the blood going from the right ventricle to the lungs, that's deoxygenated. And in the body, the only arteries in the body that contain deoxygenated blood is the right and left pulmonary arteries. And along those lines, the only veins in the body that carry oxygenated rich blood is the pulmonary veins. So make sure you know those two exceptions to the rule, because it seems like tests really like to challenge you on that, to make sure you know it. So if you have any questions, let me know.